Hello, today we're going to look at our study on 3D shapes. We're going to talk about different types of 3D shapes we might have. We're going to talk about the surface area of those, and eventually we get to the volume of those 3D shapes. We might break this up into two videos. It just all depends on how far it takes us here into the time. So first thing I want to look at are what are known as polyhedrons. Now, this word polyhedron comes from the Greek. The poly part means many, and then hedron means faces. So a polyhedron is a 3D shape with polygons as faces to the 3D shape. So for instance, you could have something like a prism. Now a prism has rectangular sides and congruent sides or congruent polygons for their bases. So for instance, if you're looking at this pentagonal prism right here, it's a pentagon right here at the top, a pentagon on the bottom. You can't see all the way through because it's drawn 3D. And then the sides are rectangles. And we call it a right prism if the sides are rectangles. You can still have a prism that doesn't have sides for rectangles, but typically we won't talk about those in this class. You can see one right here that's not a right prism. So when I talk about prisms, I'm meaning it has rectangles for sides. So you can have that in many different ways. You can have pentagons as the bases, you can have squares, you can have triangles, trapezoids. You can have a lot of different ones here. We'll even take a look, because I don't have my 3D shapes with me right now, nor do I have a camera to video with right now. We'll look at some online, and I've included this site on our resource page for today's video. But for here we have a triangular prism, and this should work so that we can switch between them. Here we have a rectangular prism. They keep disappearing on me. So triangular, rectangular. Notice this one right here has rectangles for the sides, and then a square base there. You have a pentagonal one. That's the one we just kind of looked at, and then an octagonal one right here. So the base, it doesn't matter which way you turn this thing. This thing is rotating, we can see here. But when we fold it out, this is called our net. When we fold it out like a box being unfolded, we see that there are two congruent polygons for the bases, and then all the sides right here are rectangles. So it doesn't matter which way you spin this thing. When we say the word base, it doesn't mean that's what it's resting on. It just means, when you look at these, does it have rectangles for sides? Yes. There can be another shape like right here, but if you have two of those congruent polygons and it's rectangles connecting them, you're dealing with a prism. So you can take on many shapes. Those are just four examples that we have there. Now, pyramids work a little bit differently. You only have one base. So we can see on this pyramid right here, you have a base that appears to be a square. And as we scroll down, we can see a lot of different pyramids down here again. Once again, the base can be different, just like a prism, but the sides, however, have to be triangles. So if we look at a rectangular pyramid, here we have a rectangle for the base, but notice all the sides here are triangles. A pentagonal one right here, where the base is a pentagon, but the sides are triangles. So sometimes students get these confused when they talk about prisms and pyramids. Remember, prisms have to have rectangles for the sides, and they have two bases. Pyramids only have one base, and they have triangles for sides. And of course, we have a hexagonal one right here, where the base was a hexagon. And you can see if you unfold it, you get just one base and then triangles for the sides. Now, I want to take you through just an exercise I do with my students. Usually I have a bunch of 3D shapes if you were in class, and I show them to you, and we talk about all the differences and similarities in front of the class, and it's a good discussion. And then we look at this and see if you can do it on your own. So as we go through each one of these, I want you to pause the video and see if you can name each figure, and then unpause it and watch me talk about them. So in this first one here, I notice that I have two congruent shapes, and they're connected by rectangles, and these two congruent shapes are pentagons. So this is going to be a pentagonal prism, because the prism has two bases that are congruent and then rectangles for the sides. Number two, I see a base right here that's a triangle, and it has triangles for the sides. So this is going to be a triangular prism. Not prism, pyramid. And then over here, now notice this one, we've got a trapezoid right here, a trapezoid in the back, and then rectangles being wrapped around here. So this is a trapezoidal prism because the sides are rectangles. This one we haven't talked about, but the technical math definition of it is a sphere. Not a ball, but a sphere. All right, pause the video again and try these out. So this one, we can't assume it's a cube. Now, a cube is a special rectangular prism where all the faces are the same shape. But we don't have enough information to say for sure it's a cube. We do know it has a square base, so we could call it a square prism, where the base is a square and the side are rectangles. That's probably the most specific definition we come up with it. Technically, it's a rectangular prism also, but a square prism would work for that. Number 6 is a cone. A cone is kind of like the equivalent of a pyramid with a circular base. You know, technically it's not a pyramid because the base is not a polygon, but the base is a circle, and so you end up with a cone there. Number 7, we have a rectangular pyramid. The sides are triangles. The base, it only has one base there. Is a cylinder. All right, try out 9 through 12 here. Number 9 is kind of like number 3. We've got, once again, a trapezoidal prism. Sides are rectangles. The bases, the two congruent bases there are trapezoids. Number 10, we have a square base, and the sides, it's just one base. The sides are triangles, so we have a square pyramid. Number 11, the base is a pentagon. We have a pentagonal pyramid. And then here we've got a rectangle on the base there. We can call it a rectangular prism, or we could call it, well, yeah, that's about as far as we can go. We don't know if this is quite a square right here to look at these two sides as bases or not. So I'd say a rectangular prism. Now, as we go back and look at these different shapes, each shape shows a different net here. So you can see all these different nets, and we kind of described a net as if you were to look at a box and unfold it, you would have a net. Now, it's important to know how to find the nets, or at least be able to kind of sketch out a net. It helps us with what we call surface area. So what we mean by surface area is, look at this triangular pyramid here. If it were, say, a gift to a friend, and you were just going to wrap it up with wrapping paper, and you want to make no overlaps or folds or anything like that, you just want to cut it out perfectly and tape it to your gift, you would be finding the surface area. A lot of times we might use surface area to calculate the material needed to make a hollow object, or how much paint you need for to paint an object like this. And so it's important to be able to calculate surface area, and it's simply the sum of these shapes right here. So when you flatten out the object and make the net, you notice we get 4 triangles here. The sum of all 4 triangles gives you the surface area. Let's go back and look at prisms real fast. On the prisms right here, this is our triangular prism. Notice its net is a little bit different. It's got 3 rectangles and 2 triangles, and so you'd calculate the area of the 3 rectangles and 2 triangles, and then add all of those areas up, and you'd have the surface area there. So for instance, let's suppose we were going to know the surface area of a rectangular prism like we see here on the screen. It's a 3 by 4 by 5. We could actually draw the net out here and label those sides, and you kind of see this done on this resource page I gave you. This is the learner.org resource page. They unfold it for you there, and then they show you how it connects to those side links connect to each rectangle that's unfolded. And then we can go over here on the right and calculate out the area for each one. So pause the video and see if you can calculate the surface area of it. So as you go through this, notice this rectangle right here is a 5 by 4, so it's going to have an area of 20 squared units. Same thing with this one right here. This is a 3 by 5, so it would be 15. We're just multiplying to find the area of each one. Notice the width of this we've got labeled as 4, the height is 3, so that will be an area of 12 for that one. A 3 by 5 gives us another 15, and a 3 by 4 gives us another 12 right here. So the sum of all of the areas is going to give us our total surface area. So adding all these up, I got 94 total for the surface area. Now, with the National Council of Teachers Mathematics link that I sent you in the resources, you can also see some more nets being unfolded. So for instance, for a cube, if you click on net, you can see that being unfolded. There are other shapes besides the cube, like you have the dodecahedron, which is a 12-sided figure. In this case, it's 12-sided figure with pentagons as their faces. And so you can unfold that. I won't expect you to find the surface area of anything like that, but it's still pretty cool. You can go there, look at that site. You can spin the object around, zoom in, zoom out, that sort of thing. And they've got several others there. They just don't have, or at least I couldn't find, all of the shapes that we'll be discussing. But there's, another resource that you can have to use to look at some pretty hard to draw objects and just see how they unfold. For the net of a cylinder, now notice a cylinder has a round base. Sometimes it's a little bit harder to visualize. So I want you to think about rolling up like a poster board. So if you roll up a poster board, you get like a cylindrical shape there, so where the bases are cylinders, and the side, think about this side right here and what it is when you roll it out. When you roll it out, you get a rectangle. And this animation, if you click play, it will show you that animation of how that rolls out. So if you're making the net, you want to know what shapes you're going to get. You're going to get two circles as the bases, and then you'll get this rectangle right here. But this animation does more than just showing you get a rectangle. It tells you how to find the length and width of that rectangle. So when it gets rolled all the way out, I'll pause it. And notice that this pink line right here wrapped around the circle. So that's how I got, see how it wraps around the circle as we roll up the rectangle? And so that length of the rectangle is actually the circumference of the circle. And what makes up the height of the rectangle is the actual height of the cylinder here. So try to visualize this 3D. The distance from one circle to the next is the height or the width of the rectangle. The length of the rectangle is the circumference. So the surface area of a cylinder can be found by finding the area of each circle. So you find the area of one circle and double it, plus the area of this rectangle. And the area of the rectangle is going to be the height of the cylinder times the circumference of the circle. Now, a resource I'm going to share with you, this is, since I teach in the state of Virginia, I teach a lot of geometry, and we have this formula sheet that Virginia currently uses for their standards of learning, their end of the year test there that they give all the students. And so a lot of times when I teach geometry, we'll go through this formula sheet like right before they take the test. But most of the time during the school year, the students never see this formula sheet or don't even know it exists. And the reason why is I want my students to understand where these formulas come from. And so if we look at cylinder right here, the cylinder, they give you the volume, that's what the V stands for, the lateral area, that's what this LA right here stands for, and then the total surface area, that's what we were just talking about. So if I hand this to my students at the beginning and say find the surface area of a cylinder, they're going to look at this and just punch the numbers in. They'll know the radius and the height and they'll just calculate it out. But there's never any thought there of what does it mean to actually find the surface area and why is the surface area this? To them, if they learn it that way, they're just plugging numbers into some unknown formula and spitting out an answer, and they're not really understanding where that surface area is coming from or what it means. So I like for them to be able to break it down, like maybe have a piece of paper um, and roll it up, tape it, and actually make a cylinder, and then find the surface area there. And so then we can go back and look at the formula sheet before they take the test and say, where did they come up with all of this junk right here? Notice what it is, 2 pi r squared. What does pi r squared stand for? Oh, pi r squared is the area of a circle. And you got two circles there. So that's where the 2 pi r squared came from. And then this right here should be the area of that rectangle being wrapped around the cylinder. So remember what we said was going on with this. We said, let's look, we had 2 pi r, that would be this length, and then you should times it by h. So it should be h times 2 pi r. And so going back to our formula sheet, you see you've got h times 2 pi r. And so adding the rectangle, this is the area of the rectangle right here, this is the area of the two circles combined. And so that gives you your total surface area. So I can't do that with all of these because sometimes it becomes a little difficult. But as much as I can, I want my students to understand where these formulas are coming from. They're not just coming out of thin air. It's not magic. I want them to be able to explain it. So by the time they get to the end of the year and they're taking this, they've already done all these formulas without the formula sheet. In fact, most of the time, my students look at this formula sheet as a waste of their time because they know all this stuff in geometry already because we've done it without it, and they understand where these things come from. So that's my goal with you also, is that you understand where things come from. I could just give you this and say, here, do some calculations for me. But that's not the point. I know you know how to follow instructions. I want you to understand what's going on here. Now, just in case you're wondering, this lateral area is used a lot in these formulas. The lateral area is the area of everything but the bases. You can think of it like that. Notice the sphere doesn't have a lateral area because it doesn't have bases. But for a prism, lateral area is right here is everything but this, in this case, the triangular bases. Same thing with the rectangular prism. So the lateral area here is everything but the bases. So in this case, you got to pick what the base is, because with a rectangular prism, you could really say any two opposing faces are the bases. For the pyramid, you only have one base, so the lateral area is just the sum of the triangles. And for a cone, you have one base, just like a pyramid, but the base is a circle. So it's this. It turns out to be like a fan shaped wrapped around is your lateral area. Now, this is probably one of the few that I don't really have a good hands-on activity or visualization to give the students to say, this is what the lateral area is. But the lateral area is pi r L, where the L is what we call the slant height. And so for the total surface area on a cone, notice you have the lateral area pi r L. It won't highlight, well, it wants to highlight everything. But you have the lateral area pi r L. The total surface area is the lateral area plus the base. In this case, the base is a circle. So notice you have pi r squared right here. That's the base plus the lateral area. So as we learn these, and we can really simplify in our head what these formulas are, and we don't have to go around thinking we need formula sheets all the time or we have to memorize formulas. If you can think about it logically and you know the basic, area of a square, rectangle, triangle, and circle, you can get a lot of these right off the bat without formulas.